Okay, let's get started with the systems of inequalities, practice test number 2. Looking at the graph on the right, we see that it has a dotted line or a dashed line, and we know that means that A cannot be the answer, because if we have a solid line here, we would expect to see, if this were the answer, a solid line on the graph. So we know A is not the answer. We look at C, we see a solid line. We know that's not the answer. So the dotted line tells us that there is no solid line for our equation. And so it's either y is less than the line negative 1/3 x plus 2, or y is greater than positive 1/3 x plus 2. So there's two differences here. First of all, we can see with the shading that if we put our pen or pencil right there on the y-intercept, our shading goes up. And up is the same thing as y is greater than. So we know that this is going to be the answer. The other giveaway is that this slope is a positive 1/3, which means that we couldn't have a negative slope. So D is going to be our answer. Which inequality represents the graph to the right? We know that, remember when someone gets frustrated with you and like, why did you do that? Imagine their hands going out straight to the side. That's what we have here. We have a line that's horizontal going straight up. If we want to make it into a person, a really frustrated person saying, why? Okay. We know it's y, so we can say it's not x, it's not x. We also notice that it should be a solid line. I'm not sure. Let me erase yep, it's a solid line underneath there. So because it's a solid line, we should see a solid line, but our other giveaway is that if we put our pencil right there on the y-intercept, we notice that we're shading down, and down is the same thing as y is less than. So it can't be y is greater than. So our answer is A. Okay, graph each inequality below. I know that x, since y is a horizontal line, x is a vertical line, so I'll find -4, and I'm going to put a line through it. But first I notice that there's no solid line underneath that greater than sign. So my line has to be dotted. Now I always say put your pencil on the y-intercept. There is no y-intercept. When there's not a y-intercept, your only choice is to put your pencil on the x-intercept. And instead of you're asking yourself, should I shade up or down, you're asking yourself, should I shade to the left or to the right? So when I see x is greater than, I think about all the numbers to the right that are way greater than -4. So my shading is going to be to the right. Over here, I cannot graph until I'm in slope-intercept form, and so what I'm going to do is I'm going to subtract the 3x from both sides. I'll carry down the -y. I could write -9 minus 3x, but I'm going to write it as -3x minus 9 because I want it in slope-intercept form so I can graph it. This -y right here, it's the same thing as saying a -1y. To get rid of it, we could divide everybody by -1, which would mean that y is hold the phones, hold the horses, whatever expression you want to use. That less than sign, because we divided both sides by a negative, now gets flipped to be a greater than sign. If you put in your calculator -3 divided by -1, you'll get 3, and then -9 divided by -1, you get a 9. So there we go. We've got, to graph it, our y-intercept is 9. And then our slope is up 3. You can extend this graph if you'd like, 1, 2, 3, and then go over 1. But sometimes what you can do when you run out of room and you don't feel like extending your graph, you can do the exact opposite. If the slope is up 3, 1, 2, 3, and to the right 1, I can also go down 3 and to the left 1. See how that gives me a point on the same line? And because I don't have a solid line underneath that greater than sign, I'm going to have to make this a dotted or a dashed line. And I'm going to shade. It says y is greater than. I'm going to put my pencil right there on my y-intercept. And it says greater than. That means I shade up above the line. So all my shading, don't want to go, well, I'll just go through the problem. All my shading is up above the line. Now I have to, oh, I'm done. There's only one problem here. Awesome. All right, The next section on your test is where you're going to have to match things, and then we're going to have to actually graph a system of inequalities. So here we go. We see that we've got y's and x's, and maybe the best way to go about this is just to look at the graph. When I look at graph A, I see that I have a dotted line on 5. So I know I'm looking at y is greater than 5. Well, there's only one of 5, 6, and 7 that match up that even have a y is greater than 5, and that's going to be 7. We can also double check. This says x is less than 7. There's 7. There's that dotted line through 7. That's x is 7. And then if we shade, we go to the left. Note that if we really were to do this and show both shadings, what you would see is you would see shading like this. Then you would see shading like this because it's right? It's x is less than 7. And then where they overlap is the answer. So all you're seeing on these matching ones is the answer. You're not seeing the other work. All right, when I look at B, I see that I've got y is less than or equal to 7. And there's only one thing that says y is less than or equal to 7. So that's B. And then, of course, that is y is greater than 4. And it makes sense that this would be C, but let's just double check. X is less than 7. Yep. X is greater than 4. Yep. Those match. All right, we've got y is greater than 1, and we know that y is a horizontal line. And because we don't have the solid line underneath that greater than, we have to make it a dashed or dotted line. It says y is greater than, so I put my pencil on the y-axis, and I know that greater, or the y-intercept rather, I know greater than means shade up above the line. So my shading is going to be above my line. Okay, now I'm going to switch colors for my second one. It says y is less than or equal to x plus 3, so I know that my y-intercept is 3. And my slope is up 1 over 1, up 1 over 1. Because I have this solid line here, I know that my line is going to be solid. And it says y is less than. That means when I put my pencil on my y-intercept, less than means down. That's the only choice we have, up or down, unless we're dealing with an x-intercept, then it's left or right. So less than means down, which means I'm going to shade below my line. Now, here's the deal. I didn't have to shade all of this stuff that I just shaded because I know it's not going to be part of my answer. I can see where my answer is going to overlap. And that's where I'm going to take my highlighter or marker, whatever I've got, and I'm going to say this line is part of the solution. This dotted line here is the fence that holds the solution in, and this is also the solution. So the solid line and all of the red squiggles are my answers, but the dotted line is important because it's the fence that holds the solution in. It is not, however, part of the solution. Okay, when we look at number 9, we've got to, I'm going to do this one first. I want to get my y by itself, so I'm going to subtract 2x on both sides. I'm going to bring down my negative y. I could write 6 minus 2x, but I'm going to write negative 2x plus 6. It just helps me when I'm graphing to see it in slope-intercept form. I'm almost done. See this negative right here in front of my y? It's the same thing as if we have negative 1y. And to get rid of that negative 1, we're going to have to divide everybody by negative 1, which gets rid of it. When I divide an inequality on both sides by a negative, I'm going to flip that less than or equal to sign to be greater than or equal to. Negative 2 divided by negative 1 is just going to be 2x, and then 6 divided by negative 1 is negative 6. So negative 6 is going to be my y-intercept. My slope is up 2 over 1, up 2 over 1. Because I have this solid line here, I'm going to connect my dots with the solid line. Because it says y is greater than, that means I put my pencil on the y-intercept and I say to myself, I'm either shading up or down. Greater than is up. That means I'm shading up above my line. And I would and keep going that way and go over all the work. Okay, so now I'm going to erase this so that I can do the same thing with this second part. I want to get, I'm going to look at this again. I want to get y by itself, so I'm going to subtract 2x from both sides. I'm going to write it this way because of how I explained. Oops, getting into the shading. Divide everybody by 3. Now, it's okay to divide by a number that's positive. The sign doesn't change when you do that. And we'll get a -4. So our y-intercept's -4. Our slope is down 2 over 3. I have to use a dashed line because I don't have a solid line underneath my less than. So I'm going to dash it. And then I see that y is less than, so I put my pencil on my y-intercept, and I say less than means down. I could shade all of this, right? But we can see that it doesn't start overlapping until we start overlapping with the green. So you'd want to take your highlighter or your marker when you're doing this and when you're doing the real test, you want to make it obvious to us that, yes, the dotted line is important. It's the fence that holds the solution in, but it's not part of the solution, but we need to include it as part of our picture. This solid line is part of the solution, and of course, all of this is the solution for this system of inequalities. This is where everything overlaps. Okay, and the next one, I believe we're going to be looking at 3 different lines. And so what I'm going to do is, let's look at the first one. We'll make that our red line. And of course, when we look at it, we've got to get y alone. So we're going to subtract x from both sides. We're going to write it as -x plus 6. We're going to divide everybody by 2. And this is where it starts to look a little funny. I'm going to rewrite this. See this -x over 2? Another way to write it, we really know that that's a -1x over 2. And I'm going to write it this way because then that makes more sense to me when I'm going to graph the line. So my y-intercept is 3. My slope is down 1 over 2. Because I don't have a solid line, I have to make this a dashed line. And it says y is less than. I put my pencil on the y-intercept. Less than means shade down. Less than means down. So I know that I'm going to have to fit 3 of these in. Hopefully it doesn't get too messy. But that is my first one. So I'm going to put this in red so you know that that matches up with what's on the graph in red. And I'm going to get rid of this so I can do the next one. The next one, let's do in green. And thank goodness we don't have to do much to this, do we? We go ahead and just find, we don't have to do anything, but just graph it. So our y-intercept is 7, and our slope is down 2 over 1. Down 2 over 1. I like to do this a little bit so we can see it is going to cross our other line. I'm going to make it a dashed line or a dotted line because it does not have a solid line underneath it. And then I see that it says y is less than. So I'm going to put my pencil on the y-intercept, and less than means down. So I can already tell I'm going to shade this in, but this part right here is not part of the solution. I'm like, ooh, it is going over the red part. We're having a lot of parts where it does overlap. So if we were done right now, we'd have to pick a third color and show our solution, but we're not done. We have one more inequality to get up there. I'm going to go ahead and do that in blue. And so the way I taught my students how to do this, I know some of you know how to do it in a different way, but the way I taught my students first semester, I said, we're going to go ahead and distribute. So I said y is greater than or equal to 1/4 x, and then 1/4 times -2. If you did that in your calculator, you would get -1/2. And you would get y is greater than or equal to 1/4 x minus 1.5. Not the prettiest, right? We could put 1.52. Here's what we're going to do. We're going to look at minus -1.5. So that's -1 and then a 1/2. I know it seems weird that our y-intercept is not on a corner point, but it's okay. And then from there, we're going to rise up 1. And I know this is going to be weird because our rising up 1 is going to put us exactly halfway in between -1 and 0. So we rise up 1 and then we go over 4. 1, 2, 3, 4. And I'm going to connect those 2 dots with a solid line. because we do have a solid line underneath the greater than. I'm going to put my y, I'm going to put my pencil on my y-intercept, and because it says greater than, I'm going to shade up. Here, I'll shade it even though I can see, no, it's not overlapping. Okay, this is where it gets interesting. Can you guys see where the blue, the red, and the green overlap? I'm going to take a black marker so I can show you. So this is part of the solution. Ooh, did I go too far? Let's see. There's no green there, so I did go too far. Let me undo that. Okay, so this is part of the solution. It stops right there. This is also part of the solution. And this is, there we go. Not the dotted, I'm sorry to say, the dotted is not exactly the solution. It is holding the solution in. But this, I believe, are all the places where it overlaps. All right, enough of that. Okay, with this, what they want us to do is they want us to plug in -2 when we see an x and -3 when we see a y. So when we do that, we're going to have, for this one, we'll have -2 plus -3 is less than 4. Is that true? Does -5, is -5 less than 4? That is true. So it works for this one. Then we want to plug it in for this. When we see a y, we want to plug in a -3. When we see an x, we're going to plug in a -2. And we're going to put this right here into our calculator. And when we do that, we're going to get what? An 8. Nope, we're going to get a, let's see, -5 times -2 is 10. 10 minus 2 is definitely 8. Is that true? Is -3 greater than or equal to 8? No. So no, it is not a solution to that system. All right. Which point is a solution to the system graph below? Well, we're just going to graph these. So when I see 3, 2, I know that that looks like over 3. 1, 2, 3, up 2. Oh, almost made it. Not quite. Not part of the solution. We're going to look at -3, -2. It's -3, 1, 2, 3, down 1, 2. Oh, yay! See how it's part of the solution? So B is part of the solution. And when I look at 4, -4, I go over 1, 2, 3, 4, down 1, 2, 3, 4. No, this is way far away from the solution. And when I look at -2, 6, that puts me -2, 1, 2, 3, 4, 5, 6. No, that is not part of the solution. So the only one that's part of the solution is B. We're going to do the same thing here. We're going to go ahead and graph -2, -3, and it's obviously part of the solution. We're going to graph -1, 2, nope, did not make the solution. 2, 1, nope, did not make the solution. And -4, 0, yep, that made the solution. Now, here's the deal. I don't like that this practice test doesn't have, so we have 2 solutions. Wonder if this practice test said, what about the point -2, 1? Let's look. We go -2, 1. That is right there on the solid line. Would that be part of the solution? Yes, that would, because a solid line is part of the solution. Can you see that? But wonder if the point was, let's see, how about -1, -7. When we get to -1, -7, we're right there on the dotted line. Is that part of the solution? No, that is not part of the solution. That dotted line is just the fence. It keeps the solution in, but it's not part of the solution. So no, that wouldn't be. One last question. What about this point right here? What about 2, -1? It includes the solid line, but it's also on the dotted line. So this one would also not be included. If you want to be included in the solution, you've got to be either a point exactly on the solid line, or you've got to be one of the points in here, because every other point, including where the solid and dotted including this point right here, that's where the solid and dotted line intersect. It's not part of the solution. It would have to be two solid lines intersecting to be part of the solution. And the last part of the test is going to be where you see graphs and you have to describe what's going on. I see the straight up and down one, that's x. So that's x is, it's shaded to the right. So that's x is greater than 5. This line right here, the blue line, I see that my y-intercept is -3. I guess I could write it down here, couldn't I? I see my slope is down 2/3. So I know my slope is -2/3 x. I know there's a y over here. And now I see that it's a solid line. And I also see that the shading is above the line. Once again, this shading is just showing the solution part. If we were to see both shadings, we would see this still doing this. So since the shading is above the line, I know above, up means greater than. So when I'm looking at this next one, I see that we have a y. The y is going through the 4. So that's going to be what? Y is, the shading is down. So that's y is less than or equal to 4. I also see the green line. And the green line is also a y, and it's going through 0. And it is dotted, but it's also shaded. It's shaded above, so it's going to be y is greater than 0. And then the third answer, I see this, whoops, I got to scroll back up. I see that my y-intercept is 6, so I'm going to write that down. And then I see that my slope is it down 1 over 1, down 1 over 1? It does look like that. So I'm going to say my slope is -1, so that my y-intercept is positive. My slope is -1x. I could have written just -x. I'm just writing that -1 too. And I know I have a y at the beginning, and then I see that my line is dotted and that the shading is above my line. Can you see that? And if the shading is above the line, that means greater than. There's no solid line because that line is dotted. Okay, and then over here we've got lots going on, 4 different lines. Let's look at the easier ones. We see the straight up and down. I know that's x. So that's going to be x, and we see a -6. We see that it's a solid line, so we're going to put a solid. We see that it's shaded to the right of the line. Okay, shaded to the right when you're talking about an x line is going to be greater than, so it's greater than or equal to. Then I see this, the black dotted line right here, that's a y, and that's also, it's going through 0, and the shading for that is up above it. It's dotted, so there's not going to be a solid line underneath it, so that's y is greater than 0. And then right here, we see that the y-intercept is 5. We see that my slope looks like what? Down 1 over 1, 2, 3. So that's a -1/3 x. That's a +5. We know y is here. And it's shading below the line, so that's less than. And the line is solid, so that's less than or equal to. And then our last one, it looks like our y-intercept is right there at -1. Our slope is, let's see. This one's kind of difficult to tell since it's dashed. What do you guys think? Up 1 over 1? No. Up 1? No, that's not going to work. Here, that looks like a dot there. So let's see. Up 1, 2, 3, 1, 2, 3, 4. So let's say that the slope is 3/4 x. We've got a y. It's dashed, and the shading is above it. So that's going to be y is greater than. And I believe that's it. Please come in for lab for extra help and make sure that you've done all of your homework, and good luck on your test.